the quotient rule for exponents. For any non-zero number a and any integers m and n, a to the m divided by a to the n is equal to a to the m minus n as an exponent. Notice that what's necessary for this to be true is that we have the same base. We may have different exponents, we have the same base. And when we have division with the same base, that's equivalent to subtracting the exponents and keeping the same base. So for our example, we have 3 to the 9th divided by 3 to the 7th. Well, that's equal to 3 to the 9 minus 7, which is 2. So that's equal to 3 squared, which would then be equal to 9. Now let's do a few examples for this. Simplify. Assume that all variables represent non-zero real numbers. The first one we have is 4 to the 3rd power divided by 4 to the 7th power. Well, if we subtract those exponents, that would be equal to 4 to the 3 minus 7. 3 minus 7 is negative 4, so this would be 4 as our base to the negative 4 power. And that's a negative exponent. We don't like that, so we're going to write this as 1 divided by 4 to the positive 4. Now, 4 to the positive 4 is 256, so this is equal to 1 divided by 256. Our next example, we have a to the negative 5 divided by a to the negative 9. The thing to pay attention to there is we have the same base. So we can subtract the exponents, write this as a to the negative 5 minus a negative 9. I'm going to put that negative 9 in parentheses to be cautious about the negative signs. We have negative 5 minus a negative 9. That would be like saying plus 9. That would be equal to a to the positive 4. Now I would like to do this one separately. A second way, we could have used that previous property we saw and write this as a to the positive 9 divided by a to the positive 5, which subtracting those would be a to the positive 4. We could apply these exponent properties in different order, and we still actually get the same result. Our next example is, and here's our numerator, negative 8, x to the negative 5, y to the 7th. And our denominator is 2 to the negative 2, x cubed, y to the 5th. Now notice that our 2 has an exponent, 2 to the negative 2. So we want to be very cautious about that. All right, now when it comes to the constants there, let's see what we can do. I'm going to rewrite this actually as negative 8. Actually, let's write that as a power of 2. So negative 2 cubed, x to the negative 5, y to the 7, divided by 2 to the negative 2, x cubed, y to the 5th. Now we can subtract the exponents on the 2's, so that would be negative, and then 2 to the 3 minus negative 2. We have x to the negative 5 minus 3, and y to the 7 minus 5. That would simplify to be negative 2, okay, negative, and then our base is a 2. Subtracting those two, 3 minus negative 2 is positive 5. We have x to the minus 8 and y to the positive 2. Well, 2 to the 5th power is 32. So this would be equal to negative 32. And I don't want that x to the negative 8, so I'm going to write this as a fraction with x to the positive 8 as a denominator. So negative 32 y squared as a numerator, and then x to the 8 as our denominator.